Okay, so intro to NFV and VNF Asterisk. So, Doug, go ahead.
Sure. My name's Doug Smith. I worked as an Asterisk guy for quite some time before I worked for Red Hat. And I also did some containerization of the Asterisk platform that I managed before this time. And I was brought into a team with Leif at Red Hat called NFV Partner Engineering. And we work with strategic partners of Red Hat to help integrate their solutions with our own, learn about their requirements, and work together upstream. So something that we do at Red Hat is it's upstream first all the time. So any work that we do is open source before it's productized.
So upstream versus downstream. Upstream means open source. So Asterisk is effectively an open source piece of software. And when Red Hat works with software and productizes it, we always start with an upstream or an open source piece of software. So let's say it's sitting in GitHub, right? And so what we'll do is we effectively will snapshot it, which we'll call a downstream, and then we stabilize it. During that stabilization process, after we've snapshotted the code, if we find a bug, we push the change into the upstream, we work with the community to get it merged, and once the community has signed off on having that change merged into the upstream source code, we'll backport that same change down into the downstream. And then that's where we basically provide software through a subscription model. So you basically purchase support, and you get access to the software that you've purchased support for, and then you have that productized version. We don't fork. We don't take a piece of software and then add a whole bunch of secret sauce on top of it. What we're providing is the same thing as what you can get in the open source model, in the upstream model. All we're doing, our value add, is to stabilize it and make it something that can be supported. Because imagine just having a piece of software that's continuously changing and trying to support that. You have to have some sort of versioning and some sort of control around it in order for your support guys not to just go crazy. So that's what our value add is, and so Red Hat doesn't fork. We don't necessarily change things. So who am I? I'm Leif Madsen. I work as the DevOps team lead on the NFV PE team. And so I help partners, automate and deploy and make sure that they're building things, kind of in an automated and repeatable fashion, and also help them to understand what upstream first is and helping partners understand how to work in an open source model. Red Hat's really good at working in open source, and we've been able to build a business around it, working in pure open source. So we help people to understand how to approach that and not to be scared of it, and how they can continue to work with that. So that's kind of what I work on. I work with Doug in automating, and so he does all the real work, and then I take all the glory. And so you go ahead.
All right. So right to the gist of this thing is, what the heck is VNF Asterisk? That's what we've got on all the material for these talks. It is a virtual network function that you can run yourself. So we've been using it to validate the infrastructure that we build. That's our job. We're infra guys. And we run Asterisk on top of it to analyze gaps in technology, to look at possibly network layouts that we could have.
Architecture design of how you can take an application and turn it into a cloud native type application.
And all of this is open source. It's on GitHub, and you can take it and run it. And that's what we're going to be doing in the later sessions. Is we're going to demo this thing. We're going to show you it running. And then in the afternoon, we're actually going to do a live deployment of the infrastructure.
Dangerous demo style.
Dangerous demo style. We literally had some stuff break last night, and we were up till 11 o'clock. And yay automation, we got everything back up and running. Anything could still happen, but that's part of the fun, and it could be the most valuable stuff that you get to see today is
us trying to figure out why it's not working.
Right, so that's a kind of, to me, an intangible in the tech world is, sure, you can understand this stuff at an abstract level, but to really have your hands on the keyboard and work through an issue is a whole nother thing. So that's what we're going to focus on later.
The other thing I want to mention too, we're going to kind of do this where are we going type slide, where we're going to throw a whole bunch of information at you on a slide, and then we're going to step back and build up to that slide. So even just us using the term VNF asterisk right now, it's fine to not quite understand right now because we're going to back up and then catch back up to that slide, and we're going to do that a couple times throughout the presentation. So we'll throw something up and be like, this is what we're going to move towards. So you have kind of a vision in your head. Okay, I kind of see as we work through each component where it fits into that diagram and that overview. And so we'll kind of throw a bunch of information at you, and then we'll step back, and then we'll build back up to it. So that's going to be kind of a theme. So if you get totally confused on a slide and it's overwhelming, just hopefully stick with us. We'll build back up to it. And then once we've built back up to it, if you see we move on to a different topic and you still don't get what we were doing there, that's definitely the time to be like, okay, I need more info. Let's step back and look at what we're doing.
Totally. So this morning, this first thing, we're going to give you some background on this, and we'll start that with our handy-dandy whiteboard of acronyms. There's a load of them, and Leif kind of pre-populated the board here for us, but if we happen to be using some kind of acronym that you don't understand, feel free to point at the whiteboard or wave a hand or anything, and we will define it. I think Leif did a nice job pre-populating it, but we need this board just as much as anyone else does because it's an alphabet.
There's at least two or three things on there. I was like, I know what it is, but I don't remember what the acronym stands for. You just kind of know what the object is, but you don't know what it stands for. So I think you do the first section.
Sure. So this is the layout for what we have for VNF asterisk. In the next couple slides, what we're going to do is break down how NFV is, what the architecture looks like, and what the game plan is. But these...
You know what?
If you guys are going to use that too, someone might just want to move that one over back because people are here.
I don't know if I can move this. Oh, I can move it.
Yeah, let's...
Nerds should never move furniture around because it always goes poorly. I'm surprised it didn't just fall down and crash. Okay. We could probably just sit, to be honest.
Yeah, actually,
it's 4 hours. I'm not standing for 4 hours.
Yeah, that's a good point. So as you can see here, we've got in this diagram 2 instances of asterisk. Flanking either side of that is SIP, which is a SIP traffic generator. And above it, we have a couple things here that we really consider important, one of which is a controller. And part of the idea behind network function virtualization is that you're going to have a control plane that's able to orchestrate what these instances of your virtualized network function are going to do for you. And when these asterisk instances come up, they kind of don't know what their job is yet. And that controller is going to push configurations to those asterisk machines to tell them what they're going to do. In our particular case today, mostly they're going to hairpin some calls. And we also have up there Homer. It's used for analytics of your VoIP traffic. And I can't stress enough that as you make your deployments more and more dynamic, that you should double down on monitoring,
logging,
analytics, all that good stuff. You want to have it. As this stuff is happening dynamically, if you don't have that paper trail, it's just a lot harder to debug. So for me, that's a first class kind of consideration. Also here we have some network segments broken out. At scale, at NFV, you're going to really need to separate that network traffic because you don't want to have congestion, and it's going to be the only way that you can scale. So in our today's deployment, there's not a lot of that segregation. That's something that we're working towards and something that we're looking at. So this is really a plan, but it kind of shows you at a glimpse the components that we have going on.
The other thing with the networks and the network segments and separating them out, as you move into more larger scale and more horizontally scaled applications and deployments, the types of networks and the speed of those networks makes a big difference. So where we're going here is, if you think of the controller and this top part of the slide, these two blue boxes at the top, you can think of what we would call maybe the control plane. And so what the control plane is kind of the thing that's orchestrating and pushing data down into the bottom part, which is what we're calling the data plane. The data plane is effectively your RTP traffic. That's the data. That's the thing that has the most traffic. That's where all your voice calls are. That's where all the high packet rates are. That's where you care about the network being super solid because jitter's a problem, drop packets are a problem. All of these things that have to be super, super well timed and well tuned, that would be in your data plane. That's where 90% of your traffic is. And then the control plane, which is pushing information in, and it's monitoring, and it's pulling logs out, and it's pulling information out of that so it can be displayed at what we would actually call a tertiary plane, which would be the management plane. So the management plane would be like your web interfaces, and that has the least amount of traffic. It's the thing that if it's a little bit slow, okay, it's not such a big deal. The control plane definitely has to be able to monitor things in real time, so it has a little bit more traffic. And then your data plane, obviously, like I said at the bottom here, is where most of your traffic is and is the most important. That's the one that has to be rock solid. So when you're building your networks out, you may build your networks in such a way that they're somewhat tiered. So in the Kubernetes world, you actually have the ability to have different like storage classes, and you can have SSD, which would be your fast storage, and you could have spinning platters, which are large amounts of block data, but it's slower. So the same thing can be done in these different network planes, where at the bottom is like your fast network, your medium tier network, and then your slow network. So this layering is going to be a constant theme of breaking things into layers and layering them on top. So you're going to see that theme over and over again, and hopefully we'll explain it relatively well. So here's kind of a high-level pod layout, kind of breaking things out. So in Kubernetes, there's these things called pods. And so a pod contains one or more containers. And so each of these kind of boxes represents a pod that contains one or more boxes in it. So in this case, asterisk A is one asterisk pod, asterisk B is another asterisk pod. And every time you instantiate one of these asterisk pods, it's going to instantiate a VoIP asterisk container, and it's going to instantiate a Homer capture agent container.
And one of the things to keep in mind here is that they're kind of logically grouped applications, and those get spun up in a pod and then they scale together. And we'll get into depth on this later on here, but it kind of shows you some of the units that we have going on and how they're grouped together.
Yeah, question.
So that pod, that's a process grid, or is that like
It's a collection of processes. So yeah, each container will have a single process running in it, and then a pod is a collection of those containers. So in the case of asterisk A, where you've got VoIP asterisk and Homer capped agent, there's going to be one process that is asterisk, and that's going to be isolated in a container from the capped agent. And to me, those are logically grouped because they're both going to use things that are shared amongst pods. And I will get into that later because I'd like to get on to the NFV port part, but
Cool.
Yeah.
1 and then 2.
Question, the pods in a hypervisor or a KVM?
So they're in this case, in Kubernetes. So it's specifically in our layout, it's Docker containers. So not VM. It shares the kernel with the host, and you could kind of look at it as like a super jail in a way. It's got
CH root to a certain degree.
right.
The namespace. At the end of the day, it's a namespace.
It's a namespace.
There's segregated
It's a namespace.
namespaces that you're attaching across networks, and that network may live in the same host.
Will your slides be available at the end?
Yep, slides will be available.
Absolutely. You know what? Skip this.
Yeah, we'll come back to this one.
Yeah.
So we've looked at this one. So maybe we should define what we're doing.
Yeah, so we wanted to give you an intro to the parts that where Asterisk involved and what we'll be looking at in the afternoon. But we'd really like to give you a background here and build up why we've done it this way and what we're looking at with network function virtualization.
Yeah, so with network functions virtualization, NFV, this is a framework that allows telecommunications operators to move to the cloud, basically, and taking their physical hardware and migrating it to a virtual machine or virtualization or a container or whatever the case may be, and applying it to a framework so that everyone kind of has a similar starting point. The actual implementation can vary quite a bit, and the actual underlying pieces of infrastructure can vary quite a bit. But using this framework from kind of a logical viewpoint and having kind of a spot where I have this thing and I need to put that Lego block somewhere. Okay, now I have a spot on this diagram of where to put that Lego block, and then you can build things up with Legos. That's kind of the way I like to think of all of this, is you have all these little Lego blocks and you're combining them together to build something larger. So NFV is, the purpose is to take traditional hardware, such as network devices, so routers, switches, firewalls, deep packet inspection, logging, et cetera, and deploying them virtually, like a computer running as a virtual machine, and generally running this on top of commodity hardware. This is exactly where Asterisk started, where we had old PBXs run by companies that would spend tons of time building these PBXs, and you'd have super long ROIs or return on investments for these PBXs, and then Asterisk came along and commoditized it, made it a piece of software that runs on a piece of commodity hardware that you could buy from Dell or HP or a white box that you built yourself. This is the same thing, except at a much larger scale for the telecommunications operators and having their infrastructure moving to this model. We've known this model for 10 years now or more. And so now this is another way of doing it, but instead of it being one small PBX component, it's the actual PSTN and migrating that. More generally, it would be more like the cell network and moving that into pieces of software and making that scale and having a framework for that. So defined by Etsy in September of 2012, via 7 of the world's largest telecommunications network operators. It was basically all conceived. They all kind of talked together, figured out what they generally wanted to do, and then Etsy basically created a working group and built a framework and built some documentation and a way for these telecommunications operators to all kind of drive towards the same type of thing. So historically, they would develop, test, schedule the deployment of their ASIC or physical piece of hardware, on a multiple year trajectory. So, taking that hardware for 10, 20, 25 years, whatever the case may be, developing it over several years, deploying it, understanding how it worked, getting it all cabled, do the testing, eventually migrate workloads onto it, and then it would sit there for, a dozen years, right, to try and get that ROI back. That's way too slow. You know how it is when you're running Asterisk and you have to fix something, and imagine that was in a piece of hardware and it's like, well, to fix that problem or to add a feature, I need to develop an entirely new piece of hardware, and your feature will be ready in about 15 years. That's generally what they're trying to move away from, because everyone else is going so fast. It's just that model does not work anymore. So they needed, as telecommunications operators, a way to move towards what we've all been doing with Asterisk for many years now. So this is the NFV block diagram. You can tell that it's built by a working group of people who have no idea how to draw because it's incredibly complicated. So I'm going to try and break this down into something that looks a little nicer. I'm sorry that the diagram is a little small. Slides will be done after, but basically this is the framework. This is what we're doing here, and we're going to go into each of these sections and understand what each of them are, and then we'll try to give examples at the end of products or pieces of software that fit into these blocks. So this is where VNF Asterisk lives, virtualized network function. So a virtualized network function is an instance of an application. So an instance of Asterisk could be a VNF. A virtualized network function can be actually built up of multiple components, so you saw pods, and where we showed that diagram of asterisks and having multiple components. A VNF can be made up of multiple components, but they're kind of logically grouped to solve a problem to a certain degree. Some virtual network functions are very simple, like a virtual router or virtual switch can be one thing. When you get more complicated, like let's say we were using Asterisk or a PBX, you may have a database, you may have a logging component, you may have the actual processing component, which would be Asterisk, or the PBX and the functionality. Taking all of those components, because none of them really are useful on their own, but logically grouping them together makes an application, that is a VNF. That is the core thing, I think, to really pull from this. It's an application. So really at the end of the day, again, using our planes, this whole bottom section here, this big large block at the bottom, this is the infrastructure. These are the applications. So here's one plane, here's another plane sitting on top of that. And they're abstracted from each other, where the infrastructure and its life cycle is different than the application sitting on top of it.
Which can improve your lifecycle management. Another thing that may be interesting to mention as well is
lifecycle management is just basically how to get from one version of an application to another. That was actually something I didn't even really understand when someone said lifecycle management. So what that is just understanding I deployed version 1.0 and I need to get all of my traffic onto 1.1 and how you manage to move between those versions of software.
Right.
That's lifecycle management. That's all that means.
Yep. And and in the case where it's in production, you're going to need to worry about how do I, maybe it's in the case of Asterisk, draining calls from one machine and then having another machine available, and then there are different strategies that you might use to deploy it and to fall back. So those are also part of lifecycle management.
Yeah, I'm very much a proponent of the migrate rather than the upgrade approach. So migrating traffic from one instance to another, doing it slowly, move a little bit of traffic. Okay, things look good, move a little bit more traffic, things still look good, migrate all the traffic, everything still looks good, throw the old thing away. Now that's your new norm, and then you scale that out. And then as you have another version or a new feature, same thing, trickle a little bit of data over to it, some calls, make sure everything's good, scale that back up, and then wash, rinse, repeat.
Another thing quickly before we move on to the next slide is, as Leif mentioned, that VNFs can have different components. They also can be chained together as well. So you might have something where you have a firewall, you have deep packet inspection, and then you have a router
or a switch.
Or those could be the components before it hits your Asterisk machines that may act as a session border controller, for example. So
your Camelio on the front could be part of the first chain, and then your Asterisk in the back could be part of the second chain, and maybe somewhere in that you have other components that does routing or deep packet inspection, or just firewalling in general, or whatever the case may be. Sure. So taking these VNFs that are all individual and then chaining them together is another kind of major aspect of this. So I'm going to kind of gloss over this one, but the element manager, this is really a thing that is a little bit historical. I was talking to our colleague Frank Starsky, and he was explaining what this was, because I wasn't really entirely sure why this was here, because it didn't make sense to me. But in a traditional network, you would have something that would be an application that would be specifically designed to do the actual deployment of the application and making sure that it was PXE booted and the operating system was put onto the machine, and it would do with accounting and logging and security issues and monitoring kind of the VNF aspect. This, in our case, is probably done somewhere else, or is done where this element manager and this VNF are maybe a little more flattened into kind of a single pane. So this EM, this element manager layer and the VNF layer, if you want, you can kind of think of them as a single layer, and they're in there logically, but it may not be quite as statically defined as maybe this diagram would explain, because we don't really have maybe something that necessarily fits into an element manager just
role. And yeah, something I guess that's also nice to point out about these diagrams is when Etsy went to make these, they were trying to cover a ton of use cases for really big scale. So depending on a more specific use case, it may be a combination of these elements. It's probably going to follow the similar patterns, but it may not incorporate every single one of these.
Yeah.
Would an element manager be like a web interface to your configuration?
That's up higher.
How about an IPS? Would that be an element manager? IP security, the modules like
Yeah. Yeah, I think, and so the question is it more like an IPS, kind of the security management of the actual application and understanding if it's secure or not? Is that? Yeah, I think that would be a good example of what this is. It's a little more traditional. Not everything will have this, but I think the idea is that there's a component that's basically the element manager layer is a little bit longer lived than what's underneath it. Kind of these things can change and be deployed and go away, and that thing is kind of making sure that it's been deployed correctly and make sure that everything is okay. I think that's kind of the idea here. Personally, the way I would design the network would probably be a little bit more inverted, where the VNF would be deployed and I would kind of monitor it from kind of not necessarily on top, but maybe a little bit more underneath. But I mean, that's just kind of how you would picture it in your head. All the components basically exist. So this is representing effectively your logging, your monitoring type, application specifically for this VNF. Business support systems, at the end of the day, this is the application sitting on top. So the virtual network function this would be more your web interfaces. This would be your,
It also may be where your billing happens too. So
CDRs.
It may be the system that's going through collecting those CDRs, creating a bill for your customers. So it's those systems that support the business end. So they may not be what's pushing a configuration to your machines or tandeming a call. It's going to be
consuming data and separating your business logic from your networking and your application logic. Like that's what it is. Again, this whole idea of planes and layers and separating things out so that what your developers are caring about and what the network role is and moving traffic is totally abstracted from your actual business logic. So what is it I'm trying to? So like an IVR, like the IVR creation and the actual like web interfaces or the CLIs or whatever that may be to actually allow for that to happen is going to happen at a much higher level. And what's actually the routing of the calls is doesn't really care about the workflow so much. That information is pushed down to allow the calls to move its way through the network in a proper way. They say root cause analysis, so this would be an application that would be monitoring the networking and understanding, okay, a failure happened, I've identified a failure, this is where the failure exists in the network, and this is why I think that it exists, and whatever the case may be. So the bottom block here is really your infrastructure. That is where everything runs on top of. So in kind of cloud native, there's kind of three pieces. There's your compute, there's your storage, and there's your networking. And these are separated resources to allow for virtualization to happen. So the compute is where your virtual machines run. Storage is where your data is stored. So where your prompts exist and where your recordings go and where it physically manifests itself in the network. And then you have your networking layer, which we'll get into a little bit more, but separating out the virtual network from the physical network can be done through one or multiple machines in order to allow for your external and your internal networking to happen. So this would be where your virtual routers might live, your virtual switches might live to connect all the compute and the storage nodes together and that kind of thing. So this is your VMware, this is your OpenStack, this is your KVM. That's what this is representing. So it's broken into a lot of small components. The bottom layer is the physical hardware resources. You have your virtualization layer, which would maybe be like your libvirt or your KVM or whatever. And then you have your actual machines that sit on top of that that are virtualized. So your virtual machines that are supplying infrastructure to the applications on top. So it's the separation of the infrastructure from the application itself. Management and orchestration, also known as MANO, this is the management plane or the management interface, your web interfaces to manage the infrastructure itself. So the infrastructure management is separated from the application. So you have maybe web interfaces that you expose for your PBXs or your applications to your customers. This would be more your developers and your operations teams. This would be their interface to understand what's happening in the backplane.
Absolutely. So as we were explaining earlier when we showed some of the early diagrams of VNF Asterisk, up above it was a controller, and that's a program that in our case pushes the configurations into Asterisk. So that's sort of our MANO solution at a very small scale.
Very simplified.
Very simplified. And as you'll see later too, we made a simple web interface so you can kind of look at what happened in there. And this is so, as Leif was mentioning, with your return on investment, your business considerations for network function virtualization is so that you can abstract these systems so that you don't need to necessarily have the more proficient technical knowledge that you're paying for. Deployed all the time to pay big money. You can abstract that, give a web interface, let somebody who's maybe more of a power user than a developer go and provision a new customer instance, for example.
So the Virt Infrastructure Manager, or sometimes called a VIM, is what manages the life cycle of your compute nodes, of your storage nodes, and of your network infrastructure. So this is what your operations team is going to be interfacing with. This could be a CLI, this could be automation, this could be your Puppet or your Ansible or your Cobbler or whatever you're using to deploy the machine. So you rack and stack a physical node into your data center or your desk or your whatever it is, wherever you have your infrastructure. And now I've got a piece of hardware, I need to get an operating system onto it. This is what manages getting the operating system onto it, Pixie booting it, getting it spun up, getting the operating system onto it, loading kind of the initial infrastructure software, so getting KVM or OpenStack or whatever the case may be onto the machine so it's ready to actually start building workloads on top of it. So this is the bottom layer. This is operations. This is pushing and getting the hardware from nothing to something usable and getting that up and running. So that's what this layer is representing here. Everything above it is the application. So that's where you see this dotted line. This is kind of your separation between your infrastructure and your application. So everything above this layer is where your application and your value add exists and where you're deploying your asterisks and your web applications and things like that. This is just the infrastructure management. So your automation and stuff like that. And not that you can't automate the application deployment because you should, but specifically hardware management and virtualization management and monitoring some of that stuff. The VNF Manager is a little higher up that stack. That would be maybe like a web application that you could build that would deploy the actual Asterisk components, or the the controller components, or the actual all the things that make up your application. Could be a web interface, could be a CLI. This doesn't really define how rich that interface is. It could be something very simple like running an Ansible playbook, or it could be literally running some CLI commands against this to deploy it, depending on how future-looking or how mature your manager is. But again, separation, management of the infrastructure from the application, from the business logic.
And what you'll see in the demos later today is specifically we're going to use Kubernetes to manage our VNF instances. So that's what we'll dive into later today.
Yeah, so Kubernetes is an example of a VNF manager, and that's what we're going to be consuming here. And then the NFV orchestrator, this is just even a higher level abstraction, and this is still a little bit fuzzy for me, exactly what is happening here. But this would be, again, probably an interface that manages either the deployment or the monitoring, or like a billing system. I think is probably a good example of what is monitoring your business logic and deploying that. And it's, again, just this abstraction of layers and breaking things apart into small components. This thing worries about that. If I have something that's separated from that, I build another layer and let it manage and have this separation so that you're not overbuilding or over architecting one single component to do all of the things. It gets way too heavy and way too complex. And then you get into this point where anything you change breaks something else somewhere else. So breaking things into small individual components that have a very specialized task is really the theme that we're trying to push here. So this diagram here is really just not to push products from Red Hat, but it gives an example of where pieces of software products fit into this diagram. So in the bottom right corner, we've got Ansible or Red Hat Satellite, or like I mentioned, Cobbler, or there's a bunch of different things that exist here. This is getting the hardware ready to go. This is pushing from nothing into getting your main infrastructure so that we can build on top of that. We might have Red Hat Enterprise Linux or CentOS would be your operating system. The very bottom part is your hardware. So I have 3 boxes. It says physical compute, physical storage, and physical network. So the bottom long blue box is your physical hardware. We have to run an operating system on top of that. Once we have our operating system, then we have those 3 larger dark blue boxes, which is your compute, which would be maybe running KVM. The virtual storage in the middle, which may be like GlusterFS or Ceph, something like that. And then your virtual network, which might be something like Open vSwitch or DPDK or Open Daylight. And then on top of that, we take all the pieces of OpenStack, and we have the OpenStack platform, and that makes up all of those components I just mentioned, make up the NFV infrastructure, or just the infrastructure in general. Now we've got our infrastructure. Now I can start running virtual machines that actually provide applications. So we move up to the next layer. Again, we have another operating system. So I have my virtual machine running CentOS or OpenShift or Atomic or whatever the case may be. And then I start running workloads on top of that. So that could be a virtual machine or a VNF or a container or a pod if it's Kubernetes or whatever the case may be. We move over to the right middle, which is our orchestrator for the actual application. So this could be if it's a VMware interface, or if it's running OpenStack, OOO, or it's running Kubernetes interfaces or whatever. It manages the life cycle of all those applications. And then we move up the stack even further, and we have our business applications. So in this case, we have JBoss middleware, which I actually know very little about, unfortunately. And we have, again, more abstractions on top of that. So again, maybe our billing or monitoring, what's going on with that, or licensing. How many, our tenant has, 10 instances, and I need to understand if they're, how are able to run that much stuff, and that they're within spec for their licenses and stuff. We don't want to push that down. We just want the application to worry about being an application and not worrying about the business logic and the billing and the understanding if you're allowed to do that or not from more of a licensing and billing perspective.
So, Leif, we're coming up on 5 minutes here before
Okay.
the end of the session. So,
I think we're almost at the end anyways.
yeah. So maybe we should.
Questions so far? Maybe we'll take a very quick 5-minute break.
Hit triple O a few times, what's that?
So triple O is the upstream project that Red Hat uses to build and deploy OpenStack. So Red Hat OpenStack platform is, so triple O is the management. It's the piece of software that builds or deploys OpenStack itself, and OpenStack is a virtual machine. It's a cloud platform.
And it stands for OpenStack on OpenStack. So you have a small OpenStack instance that you use to control a bigger one. So that way you can manage the life cycles independent of one another.
So the idea being that, okay, we have OpenStack and we have all these pieces of components that are all API driven and you can build infrastructure with it. Well, instead of building something to build that, why don't we just reconsume the same components to build a small management or orchestration plane to actually deploy our real cloud? So this would be where, so we are using OpenStack components, a subset of them, as the thing where our operators can drive the real infrastructure deployment. That's the purpose of it. Sorry, lose which?
What throughput do you lose by going to virtual?
Depends on how you build it and whether you care. Some people don't care. Like, it's more of building the VMs and being able to scale that way. I can just have more of them instead of having to manage right on the bare metal, because once you do that, you're locked into that, right? I can't throw things away. Now, there are tools that allow you to have almost zero loss. I mean, we have NUMA pinning where you can start pinning virtual machines and their CPUs to specific components on the physical CPUs so that you have abstraction and they get full access and scheduling of the machines so that we're making the best use of the processors. We have things like SROV, which allows for direct access to the network so that you have effectively no loss in network. You have line rate to the card within the virtual machine. We have DPDK that allows circumventing the kernel. So we'll get into some of this stuff. But there are components that allow you to have as close to zero loss as possible. You just have to build the network that way. Now, if you just throw virtual machines on top of OpenStack, there may be just as much loss as any other virtualized platform because you're building layers and abstractions. But there are ways to get back to near hardware, like near bare metal speed.
And you mentioned several tools to get that bare metal speed. Is it that complicated to get that? You mentioned several tools.
It can. It can be. We're talking at such a large scale where every single extra bit that I can squeeze out of the hardware makes a difference. And because we're scaling so much of that in some of these instances, that I have to, just from pure density perspective, I have to get every bit of that lemon juice out. In some cases, you may just be like, it's faster just to open more lemons, So there's this balance of, if you're a network operator, you need as high a density as possible. I need to get every single bit that I can out of it. I'm getting a better return on my time investment to build a more complicated platform to get as much out of it and as dense as I can. Some cases, you just might not have that requirement where you're like, it's just me. It's just easier. It's cheaper and easier for me to just buy more hardware than it is to spend all that time to manage with even more and more tools. So, we'll be mentioning some things that might not be applicable to most operators, but when you get to this scale, that makes a big difference. So, quick break, 5 minutes. We'll start again at 11:35.